Trying to look into a crystal ball at the future is complicated at best. Intended and unintended issues with a new technology can be very difficult to anticipate.
When Chinese researcher He Jiankui performed his gene editing experiment on twin girl embryos in China back in November 2018, he was quickly condemned by the science community, expelled from his research position, and jailed by the government for creating the first gene-edited babies.
The combination of historical practices around the world of eugenics, genocide, and overt systemic oppression of women, minority groups, indigenous people, LGBTQ, and differently abled people's rights to reproduction intersected with the current capabilities of human genome editing has fueled renewed debate on ethics, legal rights, the question of consent, and who has authority to grant consent. Overall, what began as a science technology issue has become a political, social justice, and even religious issue, sparking the demand for public debate as to the societal impacts of human genome editing now and in the future.
In addition, regulatory governance, processes, and legislation amongst countries around the world, including the US and other countries in the EU, are evolving. The question is, will it keep pace with technological progress within bioscience?
Amongst the social and ethical concerns of gene editing on humans is how our scientific and worldviews held today may impose considerable challenges and discrimination against children of the future. For example, what happens to the human race if the affluent can, quote, purchase desirable genetic traits of their offspring? Does human genome editing have a favorable future despite the potential for misuse?
Researchers seem to think so. With its focus on disease risk prevention and new discoveries in human genome editing to reverse blindness, scientists are finding ethical ways to innovate specific disease prevention at the DNA level. As of spring 2020, there are new research findings within Cas13, which targets RNA instead of DNA, to target RNA viruses such as the flu or COVID-19, which currently cannot be targeted by existing CRISPR screens since they target DNA only.
Before we go, be sure to check out our Myths Debunked infographic to bust through some of the misconceptions about human genome editing. See you in the last module.